I'm going to go ahead and get started. This presentation is about the ways that module developers can write code which alters the way that Drupal core's functionality or any contributed module works. I'm going to talk about the various different patterns that we in the community use in order to ensure that Drupal remains easy to extend and super flexible, including plugins, services, events, and hooks. My goal is to give you some example use cases for each of these. So to explain what each one is, show you some examples of what core is doing with those currently, give you a recipe for how to implement these patterns, and then links to a bunch of additional resources. It's a little bit too much to try to get into the technical details about each of these in a 45-minute presentation. And so what I'm hoping is that when you come away from this, you'll have a better understanding of what you should Google for or what you should look for on Stack Exchange when you want to implement these patterns on your own. I will also say that if you're already a comfortable Drupal module developer, you've written a handful of modules for Drupal 8, you've implemented things like plugins and events before, there's probably not a lot of new in here, but maybe. So. My name's Joe Schindelar. I'm EOJ the Brave on Drupal.org and in Drupal Slack and on Twitter. You can reach out to me in any of those places if you have questions about any of this content. And I work for Drupalize.me. So backing up a little bit before I dive into this too much, in the Drupal community, at least for as long as I've been involved, there's been this motto, which is don't hack core. These three words to me represent this idea that as a module developer, as someone who writes PHP code, I should be able to alter Drupal's functionality or make changes to the way that Drupal works or add new functionality without ever having to modify the code that makes up Drupal core. And that's part of what makes Drupal such a flexible and reusable and versatile system. From another perspective, what this means is that my Drupal core code is the same Drupal core code that everyone else is using. This makes it easier to do things like get support, apply security updates. When you update from Drupal 9.0.0 to 9.0.1, if you have not made any modifications to the code, that update should be as easy as just dropping in the new set of code files on top of your existing ones, and you're done. If you've made changes to the code, though, you might have patches that you need to reapply. Best case scenario, worst case scenario, you've made changes that you don't even remember, and now you've updated, and sometime in the future, someone's like, hey, how come this thing that we fixed previously isn't working anymore? So the motto is then, don't hack core, and instead find ways that you can override its existing functionality or extend it. In addition to core, this also applies to modules from Contrib or even modules that you write yourself. You can take these patterns and you can implement them so that your custom modules can be extended by other people's code without them needing to make modifications to your module. And this is super powerful. You think about a module like, for example, the voting API module, which is a module that allows you to collect votes from a person and then tally up those votes and display them in a result of the counting of those votes. And if you take a second to think about this, you can imagine how a voting calculation, a simple version of that would be a poll. Everybody gets one vote, it counts for 1 point, you add them all up together, and that's the result. You could also have different styles of voting, like instant runoff voting, or maybe you've got a unique case where you need to have votes weighted differently depending on whether it's cast on a weekend versus a weekday. And if you were the maintainer of the voting API module, people are going to come along and start asking you for all of this functionality that is super specific to their use case and kind of has no bearing on your use case. And it's certainly not something that you want to maintain. So instead of including all of those different tallying mechanisms into the logic of the voting API module, you could implement some of these patterns in order to allow other people to write modules that extend yours and add new ways of tallying votes so that they can meet their application specific needs, but still take advantage of all of the other things that the voting API module provides. I think this works because we have different established ways that we can write code that talks to or communicates with other code. And in the context of Drupal, I think it helps to have some idea about what that communication might look like. So you might, for example, want to write code that responds to some kind of information or event that is taking place. For example, when a user logs into the site, Drupal will announce, hey, a user just logged in. Do you want to do anything about it? Because if you do, this is your chance to do that. So you can respond to an event. You might have scenarios where Drupal wants to ask a question. Someone just navigated to the blocks layout admin page. Drupal says, hey, I want to give this user a list of all the blocks that are available on the site. Does anybody have a block that they'd like me to add to that list before I display it for the user? You might want to write code that provides entirely new functionality that doesn't currently exist in Drupal and plug it into the system, like, for example, voting API, so that it can be used in your application. And finally, you are likely to run into scenarios where Drupal's existing functionality doesn't work quite the way that you want it to. And so you want to make a change. Like, for example, changing the criteria that are used when validating a user's password, or even changing the fields that are available on the form that a user uses to log in. These methods of communication don't necessarily map directly to the 4 different approaches, plugins, hooks, services, and events. Each of them, there's a bit of overlap in each of them, but I think it helps to sort of contextualize that and have a better understanding of how elements of code and why they're communicating with one another. So if the mottos don't hack, and you can't make changes to Drupal core's code, what should you do instead? The best practices that we've established thus far in the Drupal community are using hooks, writing plugins, creating new services, and subscribing to or dispatching events. And I'm going to talk about each of these in quite a bit more depth. I'm going to start with plugins, because I think if you're new to Drupal module development, of these 4 systems, plugins, I think maybe hooks is the one that you're likely to encounter first, and is probably the one that you'll also implement the most frequently. So what are plugins? Plugins are a way of extending Drupal's functionality. They're commonly used in the scenario where Drupal needs to provide an administrator with a list of things, and then the administrator can choose one or more of those things to be active, and then configuration can figure out which of those to use in a given context. Think about something like blocks or field types. Modules need to be able to provide any number of new blocks. They all have essentially the same functionality: display a label, display the content of the block when it's viewed within a region, but they might go about doing so in different ways. In most cases, plugins are going to be a combination of a PHP class that implements a specific interface and some metadata about the plugin instance, usually in the form of a PHP annotation. I'll talk a bit more about that. There's also some instances of metadata-only plugins. Usually those are written in YAML, and they can provide their full feature set via arguments. So there's just a single class, and when the plugin is instantiated by Drupal, it reads in the metadata from YAML, passes it to the class constructor, and the plugin class can figure out everything that it needs to do based on just some logic within the PHP itself and the arguments that you passed in. And there's no need for you to write unique logic within a method. I have some examples of those as well. I also think it's important to remember that plugins it's more of a design pattern, similar to how dependency injection might be a design pattern. Plugins themselves are not a finished product. There are lots of implementations of this design pattern throughout Drupal core, and each one of those has a little bit of nuance to it. I'm going to try to cover the parts that are common to all of them. Examples of things in Drupal core that are plugins. I mentioned blocks already. Field formatters, views, row styles, actions. Again, anything where you could imagine Drupal providing an administrator with a select list of options to choose from, and then they can configure one or more of those to be active. I sort of mentioned this already, but blocks, I think, is the easiest example of a plugin to conceptualize. And if you were going to implement this from a purely code perspective, you can imagine how blocks in Drupal are classes, and each block is an extension of a base class where most of the things are shared. For example, or they have a lot of common features. It has a label that you need to be able to display in the admin UI. It has the need to display a configuration form. It needs to generate content, but that content might be static content that you just type right into the code. It might be querying the Twitter API and pulling information in from there and displaying it on the page. And so that's kind of the classic example of a block, or sorry, of a plugin. The plugin system consists of two different main components. There are plugin types and then plugin instances themselves. So blocks is an example of a plugin. Plugin type, or oftentimes referred to as is the code that determines the sort of definition of the problem that you're trying to solve. What is a block and what should go in a block? Or how should, the problem might be, how should the text of this that's in this field be formatted in the case of a field formatter? And so your plugin type determines essentially the PHP interface that you need to implement in order to create an instance of that plugin, as well as where you place that code so that the system can discover it, and how, once it's discovered your code, Drupal can instantiate the code at the time that it needs it in order to make use of its functionality. The second component of the plugin system are plugins themselves. So, and we use the word plugin or plugins to refer to an individual instance of a plugin type. So you would have a block plugin, like the system information block is a plugin that is of the block plugin type. Plugins are always defined as being of one specific type. And they, like I mentioned before, are primarily PHP code and metadata. The reason that we define some of this metadata outside of the code is so that the plugin manager can do things like get a list of all of the different block types and maybe their admin label and list them on the page without having to load all of the PHP classes into memory and instantiate a copy of each one of them just to know what the admin label is. So we use metadata for some of those types of things in order to speed it up. If you want to implement a plugin, the recipe for doing so is you first need to figure out what type of plugin it is that you're going to implement. So you might be implementing a block plugin or a field formatter plugin. Once you know what type of plugin you're implementing, that's going to tell you a bunch of information that you need to complete the rest of these steps. Effectively, where should you put the metadata for the plugin, and where should the code go so that Drupal, or really the plugin manager, can discover it when it wants to use it. Once you know the type of plugin, assuming it's a PHP-based plugin, the next thing you're going to do is see if there's a base class provided by the plugin manager that you can extend. And in most cases, there is. I believe that in Drupal core, for every plugin type, there is a base class that you can extend. Now, you don't technically have to extend the base class, but in most cases, you'll probably want to. It helps reduce boilerplate code, takes care of common functionality that things like, for example, blocks all share that you could, if you want to, override, but in most cases, you probably don't need to. You know, maybe the block plugin base class implements the code that is required to perform access control for who can and cannot view a block. In 90% of use cases, you're fine just saying, I'll use whatever the default is. But if you want to, and you extend the base class, you could override that method and change it for your specific use case. And then finally, once you know if there's a base class or where it is and you can extend it, you just implement the PHP interface, which is again determined by the plugin type, and provide the metadata that the plugin type is requesting. I can show some examples of what that looks like. This is an example of a PHP-based plugin. So this is an implementation of a hypothetical plugin for ice cream flavors. There's a discovery component of it. So up at the top, the PHP namespace here is how the plugin is discovered. As long as my class exists in this plugin/flavor PSR4 namespace, the ice cream flavor plugin manager is going to be able to discover it when it needs to make use of it. Here's the metadata that I talked about. In this case, it's in the form of an annotation. So the part of this comment, it's a PHP comment. It's in a special format. The part that starts with @flavor looks almost like a function definition in the comment. That's the annotation. That's the part that the plugin manager knows how to read to get metadata about this class, really, without having to instantiate the class. This is a sort of common format for those. What goes into the metadata here is determined, again, by the plugin type. And you usually figure that out through the documentation for that plugin type. And then finally, there's the PHP that is implementation of, in this case, extends the base class. The base class is an implementation of a PHP interface. That interface says, if you want to be an ice cream flavor plugin, you need to have a slogan method, and it needs to return a string. And so that's what's happening here. I also said that there are metadata-only plugins. They're defined usually via YAML. And in that case, or in this case, the definition of the plugin is just metadata, and there's no code required. Some common examples of this in core are things like menu items, breakpoints, a lot of elements of the routing system, where again, there's just a single PHP class that the plugin manager will load that class and pass in the data from your YAML definition here to the class, but then the menu link plugin class can figure out everything that it needs to display on the page just by what you've passed in as the metadata here. So if that's the recipe and you want to implement a plugin type, you need to know what plugin types exist, some ways that you can go about figuring that out. If you've made use of the Drupal console command line tool before, it comes with a handy command debug : plugin, which you can run, and it will give you a list of all of the different plugin types for your current code base. I really like this approach because it will also dig into any contributed modules that you have and discover plugin types that maybe they implement. Another thing that you can do is search for any classes that are in the annotation namespace. This works because currently, at least, the plugin system is the only part of Drupal core that makes use of annotations. And so if you find all the classes in the annotation namespace, those will help point you in the direction of the various different plugin types. Those classes also serve as the documentation for what you should put into the annotation when you're implementing a plugin of that type. And then finally, since every plugin type is defined by a plugin manager service, you could just search for all of those services as well. The way to do that would be to look for the services prefix with plugin.manager. This is a common convention, but it's not a requirement, so it might not find all of them. Those are some different approaches to figure out the various plugin types that are available. If you are a module developer and you want to allow people to extend your module's functionality with plugins, like, for example, add new ways of tallying votes, you might want to implement a new plugin type. And the recipe for doing that is this. You create a new plugin manager. Plugin managers are almost always created by extending the default plugin manager, just because it does a lot of things for you automatically and there's no reason to do them again. When you write a class that extends the default plugin manager, you'll need to teach it what the discovery method is for your plugin type. So essentially you'll tell it, this is the PSR4 namespace that you should look in order to find plugins of this type. You can tell it how you would like to instantiate copies or instances of a plugin. So once it finds an ice cream flavor plugin, how should it go about loading that class and sort of what data should it pass to the constructor of that class when it's making use of it. And then what you'll want to do is define a PHP interface for your plugin type, and probably a base class as well. You can think of your interface as sort of the contract that plugin developers are signing that says, hey, if I'm going to write a plugin of this type, these are the things that it needs to be able to do. It needs to have a method called slogan so that after my plugin manager instantiates it, without really knowing what flavor we're talking about, it knows that it can call the slogan method and get back the data that it's looking for. Here's a list of resources for learning much more about the plugin system and both how to implement individual plugins as well as new plugin types. These are all also in the link that I provided at the top of the chat for the slides. And I'm just going to keep going because we don't all need to look at a bunch of links together. The next one I want to talk about is services. So services are a way of encapsulating your application's business logic into sort of a reusable utility that can be accessed by other code in the system in order to make use of it. You can think of this as sort of a replacement for what is often done as like global functions and sort of, or functions that are in the global scope in PHP. In contrast to plugins, because these are going to both essentially be PHP classes that you define. Remember, plugins are useful in the scenario where you have possibly many of them active at any given time, and an administrator needs to be able to choose which ones are used, how many of them where they're displayed, or whatever the case, like blocks. Services, you can have multiple different services that all perform the same task, but only one of them is going to be active at a given time. A really good example of this is the database service. So the default database service connects to a MySQL database, but you can write database services that connect to other types of database like Postgres or MS SQL. Any given Drupal application is likely to only have one of those services active at a time, even though they all perform roughly the same functionality. So like I said, services are useful as global utilities. They work because you're implementing and defining and implementing an interface. Code can consume that service, and based on the interface, it knows how to make use of it. It knows it can call the query method in order to make a query to the database. Services can be swapped out with one another. So typically the pattern is you'll implement a service that contains your business logic, and then you would inject that service into, say, a controller. You're gonna write a page, or maybe you're gonna write a new block type. You could inject this service using dependency injection into the block plugin type, and then that block plugin could make use of the service in order to query the Twitter API, perform whatever calculations your application needs to, and then display the results. These services, because they're used via dependency injection, you can then swap them out for one another. The example that I had written down here was you might have a mail sending service. So your code gets an object name, something like $mail, and it knows that it can call methods like setHeader or send. It doesn't have to care what happens in the background when it does that. It just needs to know that it can call the send method and the email is going to get sent. Depending on which service was in use, that might be sending mail with PHP's built-in mail functions, or via the MailChimp API, or an SMTP server, any number of different things. Because services are typically injected into your code via dependency injection, it makes that code generally easier to test, because you can do things like write a mock service and use that when you're running your tests. So if your test relies on the mail service, at the time that you're running tests, you probably don't want to send out a bunch of emails to everybody. So you can swap in a mock that says, oh yeah, I sent that email. Yeah, sure thing. Even though maybe in the background it did nothing. I also think that services allow for better code reusability. In a lot of cases, I think what you'll see is services tend to be sort of a thin wrapper around a class that contains your business or application specific logic, maybe a composer PHP library. So that mail service that implements the MailChimp API, probably what it does is it's a class in Drupal that loads the MailChimp PHP SDK and exposes the functionality that it provides, but it does so as a Drupal service. That PHP SDK that MailChimp provided, you could use in any number of different PHP applications. They don't have to be Drupal. And so now that business logic code is more portable between different systems. Some examples of services in Drupal, I already mentioned the database access layer. Another common one is caching. For example, by default, Drupal will store cache records in the database, but you could swap in a different service and store those cache records in something like Memcache or Redis instead. There's a service that's used for optimizing JavaScript and CSS assets. What it does is it compresses them all together into a single file. You could swap that out for a different one that maybe minimizes your CSS in a different way. Plugin managers are services. Actually, all of these other patterns, hooks, events, and plugins are defined. The business logic of those patterns is defined as a service. You'll commonly see services used, as I mentioned, for third-party API integrations. There's a whole bunch of things. Basically, if you're getting to a point where you're starting to write PHP code that is sort of like, this is the code that's specific to my application. This is the business logic. It's what makes my application unique. I would say define that as a service and then consume that service via a controller or a plugin or a hook or an event or anywhere that you might want to make use of that application logic. If you want to discover what services available, the best way to do that is to go to api.drupal.org and click on the link over in the sidebar that says services. This will give you a big list of all of the services that are available in core. I suggest you take a minute at some point to go and familiarize yourself with that list, and just what it essentially is like, here's a big list of all of the utilities Drupal provides me as a module developer that I can make use of to do a whole bunch of different tasks without having to re-implement that service on my own. If you want to implement a new service, the recipe for doing so is you need to choose a unique name for the service. My tip would be to always prefix your service name with the machine name of your module. So like votingapi.service or whatever you want to name it. Then define a PHP interface that is the contract for that service. So it might be if you're creating a new mail sending service, you might define an interface that has methods like setHeader and send, and use that as the place where you provide documentation for others and future you about what that service does. You then need to register your service for Drupal by creating a .services.yml file in the root of your modules directory. I have an example of what that looks like in a second. And then when you're ready to make use of the service, say within the context of a block plugin where you want to allow someone to send an email, you use the dependency injection container or the services container to instantiate a copy of that service. It will return to you an object which you can then make use of in your code. You want to use this approach, accessing it via the service container instead of just invoking the code directly, because this is what allows it to be swapped out as needed. So configuration could say, hey, when they ask for this service, I actually want to load this other example, this mock instead. This is an example of what it looks like to declare a new service for Drupal. Effectively, you are creating a YAML file with a bunch of metadata. Breakpoint.manager here is the unique name of the service. You're telling it where is the class that is an implementation of this service. Arguments, you can say any other services that yours depends on. So you can see that the breakpoint manager also depends on the cache discovery service, the string translation service, and then additional metadata in some cases like tags. I'm showing the example of tags here because we'll talk about that more when I talk about implementing events. If you want to learn more about services, there is a big list of resources. Again, we'll browse past that quick. The next pattern I want to talk about then is events. So events refers to the scenario where your code needs to be either a broadcast or alert other people about some action that is taking place, or subscribe to be alerted about the fact that something has taken place. This is like, for example, when you sign up to get text messages whenever there's a tornado in your neighborhood, you're subscribing to an event, and then some event dispatcher somewhere says, hey, there's a tornado taking place. I'm going to send out a message to everybody's phone, letting them know about that. So events are a really common OOP, object-oriented programming design pattern. They're used in JavaScript a lot. This isn't unique to Drupal at all, but the way that Drupal implements this pattern is kind of what we're going to get into here. And I just sort of mentioned they're used to accomplish the scenario where some element of code would like to communicate to another bit of code that something is happening, or respond to the fact that something is happening. As an example, if you're familiar with JavaScript, you've maybe seen things like writing code for onClick. So the event is click. On the click event, run this code. It's similar here. The event system is made up of two components: dispatchers, which is how you announce or broadcast. You say, hey, something's happening. Do you want to do anything about it? And then subscribers, which are a declaration that you would like the dispatcher to notify you whenever a specific event happens. Some examples of events in core. There are actually not that many currently events dispatched by Drupal core, and a lot of them are actually dispatched by some of the Symfony components that Drupal core makes use of. So a lot of them are really low-level events. But some of these examples are config events.save. So these are the example event names. Whenever a configuration object is saved, Drupal, so you fill out the form that changes the admin email address for your site, and you hit save. Drupal dispatches an event, and it says, hey, someone just changed the system information email address. Anybody want to do anything about that? If you do, now's your chance. There's some low-level, really low-level events, like the kernel events, which refer to the Symfony kernel. And they mostly deal with routing. And it's basically like, this request just started. Do you want to do something? This request just terminated. Are you interested in knowing about that? The Migrate API also makes heavy use of events in order to allow you to do things during the process of importing data. So for example, if the Migrate API might consume a CSV file before it saves a record, from that CSV file, it'll say, hey, here's the data I got. If you want to make any modifications to it real quick before it gets saved, now's your chance to do it. So those are some examples. I see the question, why are there so few uses of events in core? And I will address that shortly. As an example of how to subscribe to an event, there's three parts to this. So the first thing you need to do is determine the name of the event that you want to subscribe to or be notified about. I'll show you how to do that in just a second. Once you know the name of the event, you actually need to define a new service that is tagged as an event subscriber. So this is just the same as implementing a new service like we talked about earlier, with the one exception here where it has to have this special event subscriber tag. And what it does is then points to, it says, when this event is triggered, load this class, the Tommy subscriber class, and call a certain method on that class. The reason that Drupal requires you to do it in this way is for performance reasons. It allows the list of events that are dispatched and who is subscribed to those events to be statically compiled into the service container so that it doesn't need to figure this out at runtime whenever events are dispatched. And then you need to implement the PHP code that you want to run when the event happens. So you do this by writing a class that exists within a specific namespace and implements the event subscriber interface, which largely amounts to you write this get subscribed events method, which returns an array that is a list of the events that you would like to subscribe to, and the code, the method in this case, that you would like called whenever that event is triggered. And then in that method, I would put my custom information. Whenever an event is dispatched, the thing that is subscribed to it will get this $event object. It's sort of the message that's passed along about whatever action is taking place. So you can get some additional context in order to react. If you want to dispatch an event, so you're writing a module and you would like to announce to anyone that cares that a specific thing is happening, the pattern for doing that is to start by adding a new class in the. This is sort of the documentation of your event type that you're going to dispatch. You would then author a class that extends the existing event base class. And this particular code you can think of as like the message that's going to be sent along with the event. So whenever the dispatcher is called, it will say, make a copy of this class that's in this, that implements this, or extends this event base class and contains whatever logic I'm going to put into it about what's happening. This is what I want you to know about what's happening. And then get a copy of the event dispatcher service from the service container, call the dispatch method, and pass along an instance of the event class that from step 2 that you want to pass on to whatever code it is that's listening. If you want to find all the existing events that exist, there's a couple of different things that you can do. You can search through your code base for the string @event. In Drupal core, at least, the convention is to add that PHP doc block into the documentation for any class that implements an event. I really like the web profiler module that comes with the Devel module. So if you download and install the Devel module, there's a sub-project called Web Profiler, which you can turn on and configure it in a way that for every page or every route that you visit, it will display a list of all of the events that were triggered in the process of building that page. I find this really useful to be able to say, like, I want to change something about the way that the login page works, but I'm not quite sure what the name of the event is. This will give you a good idea. And then the Drupal console utility also has a debug:event command, which is useful. A big list of links. And finally, I want to talk a little bit about hooks. Prior to Drupal 8, hooks was the pattern that we used for everything. So we didn't have plugins, events, and services up until Drupal 8. Until we started implementing some more object-oriented design patterns. And hooks still play a really important role in Drupal. There's still a ton of them that exist. This is changing over time as these other patterns like plugins and events become more widely used, but I do think we'll continue to see hooks used for a while. Hooks are PHP functions. They're functions that are declared in the global scope. So they're accessible from anywhere within PHP, and they follow a specific naming convention. In some ways, they're kind of the easiest of this pattern. If you create a new function and it has the right name, Drupal will call it at the time that it needs to call a hook. Hooks are used currently in a lot the same way that we use events. They're a way for a module to broadcast, hey, this thing is happening. Would you like to do anything about it? For example, this node is just being saved to the database. Hook node save would get called, and anybody that is implementing it has an opportunity to make modifications to the node object before it is saved. I kind of mentioned this before, but for past versions of Drupal, hooks were the workhorse. We use this for everything. Excuse me for a second. Hooks work really well for the scenario where you need to alter an existing set of data, an existing something. Some common examples of this are forms. So every time that a form is displayed in Drupal, that form is defined as a really large associative array. And it's passed to, in order to build the form, Drupal takes that associative array and transforms it into the HTML that you see on the page. Before it does that, it says, hey, does anybody want to make any changes to this form? And so it passes that array, the form definition, to all implementations of hook form alter, which can then, because it's passed by reference, those functions can make changes to the array, and whatever changes they make will persist back upstream and affect how the form is displayed. Hooks work really well for this, and they can do it super fast because effectively all you're doing is calling a PHP function and passing an argument by reference. A large part of the reason that hooks are still used for a lot of cases that also sound like something that you could use an event for is performance. And in older versions of PHP, I don't know all the nuances of this, but I do know that at the time that Drupal came out, older versions of PHP, there were some limitations to the way that Symfony dispatches events, making it considerably slower than just calling a PHP function and passing an array. My understanding is that that is changing. Dries addressed this a bit in the keynote on Tuesday, talking about how one of the biggest complaints from developers is the fact that there are hooks and there are events, and like, which one of these should I use? So this is a thing that the Drupal community is aware of and working on resolving. I don't see it changing. It's certainly not going to change in the lifecycle of Drupal 9. So at least for now, there are a lot of hooks and you will still need to know how to implement them. But I do think this will change over time. Example use cases for hooks. I already talked about altering forms. That's one use case. Another place that I see it used frequently is scenarios where Drupal has gathered a bunch of information or metadata about a particular system and then wants to give you an opportunity to modify it before it acts on it. Entity definitions are a common example of this. So entities are, a lot of metadata about entities is defined as annotations because entity types are plugins. After the plugin manager gets a list of all that metadata, some of which might point to, for example, here's the class that you should use when you instantiate a new node. That list of information can be passed on to a hook, which could alter it. So your module could say, you know what, for article node, use my article node specific class that extends the base node entity and adds some custom logic that I have. So you could do something like that with a hook. And finally, hooks kind of respond to what are typically events like save. This is being saved. Do you want to do anything about it? If you want to implement a hook, what you need to do is determine the name of the hook that you're going to implement. So example, hook underscore form underscore alter is the name of the hook. Then you need to add a function in your .module file, or really any other file that's going to be in the PHP global scope, following a specific naming convention, which really just amounts to replace the word hook with the machine name of your module. So if my module is named example and I want to implement hook form alter, I'd create a function named example underscore form alter, and then I would implement that function according to whatever the documentation told me I should do. Finally, if you've just defined it, you want to make sure that you clear the cache because Drupal 8 and above keeps a list of all hook implementations cached. It's kind of like a registry of the system for performance reasons. Here's an example of what that would look like. This is an implementation of hook user login where the system module is implementing the hook and it's saying based on some configuration, would you like to require, not require, but would you like to suggest that all users have a time zone configured for their account? And if the configuration says, yeah, do that, this hook implementation will, whenever a user logs in, if they don't have a time zone configured, display a message that says, hey, you can configure your time zone by going here. The way to find existing hooks that you can implement, the best way to do that is looking in the root directory of a module for .api.php functions. This is where the canonical documentation for hooks exists. This has been true since basically forever. And you can also go to api.drupal.org, and there's a complete list of all of the hooks implemented by Drupal core there. If you want to invoke a hook, so if you want to allow someone to, for example, alter metadata that you've gathered, you need to pick a unique name for your hook. Again, I suggest prefixing it with the name of your module as an easy way to ensure that it's unique. And then use the module handler service and call one of the methods available on it. Generally, you'll call it either invoke all or alter. Alter you would use in the case where you would like to pass in the first and second arguments to the hook by reference so that the implementations of the hook can make modifications to the data. or alter. You can learn more about hooks in these locations. I talked about this a bit already because it came up, but sort of hooks or events, they sound a lot alike. I agree. They essentially accomplish a lot of the same things. Also true, it's very frustrating. How do you know which one to use? Or like, how do I decide? Should it be a hook or an event? And this basically amounts to, if you're going to try to respond to some other code's message, you have to implement the pattern that they've used. So if it's dispatching a hook, you have to implement a hook. If it's dispatching an event, you have to subscribe to the event. There are some ways around this. There's a contributed module that tries to sort of grab all hook invocations and throw an event when that happens. I've not tried it, but is a thing you could explore. Going forward, the community seems to be standardizing on events. So if you're going to implement one of these patterns in your module where you're going to say dispatch something, I would say in most cases, dispatch an event, unless for some reason it's not working or doesn't make sense. Quick recap, there are 4 methods that we can use primarily to extend Drupal core or contrib plugins, services, events, and hooks. All of these are there so that we can alter the way that Drupal's existing functionality works or add new unique functionality without having to make modifications to Drupal core or contributed modules itself. That's what I got. Again, you can check out this link for the slides. Thank you so much for coming. I don't think this room closes down right away, so I'll stick around and try to answer questions, but I also want to recognize that it's the top of the hour, so if you wanted to jump onto the next thing, please do. Thank you. And now I will try to questions. Let's see. I'll try to scroll back, but if I miss your question, feel free to post it again. One of the questions is, could alters be replaced by events in the future? The answer to that is yes. You could do that now. You could dispatch an event in the event object that you pass along. Since objects in PHP are inherently passed by reference, that you could dispatch an event, pass an event object, the subscriber could make modifications to that event object, and then in the code that made the original dispatch, that event object would have those modifications applied. I know that for technical reasons, in older versions of PHP at least, there are some performance implications to that. Largely, I think it has to do with the fact that there's just like the process to bootstrap and dispatch an event is a lot more code than the process of just calling an existing function. We talked a bit about why there are so few uses of events in core. You all said you could hear me. All right. Was Joe the Brave already taken in reference to my username? So if you didn't figure that out, EOJ is Joe spelled backwards. It wasn't already taken, but at the time that I picked the username, you were supposed to like pick a name that would keep you anonymous so that you could remain anonymous on the internet. In retrospect, I wish I had picked a username like joe.shindelar, but I got EOJ the Brave instead. And now I'm stuck with it for perpetuity. Cool. One of the questions was, do we have any Drupal courses out there? Yes, in fact, there are a bunch. I work for Drupalize.me. We produce courses that cover a lot of this material. There are also a number of other good resources for learning Drupal. Yeah, a bunch. Cool. And if you have questions later on, like you go back to work next week and you're trying to implement any of these patterns, like I said, hit me up in Slack or on Twitter. I'm always happy to try and help people figure out how this stuff works. Thanks again.